You can just I say last time we did electrophilic. So I'll just give you a brief overview or a recap. Okay, what was electrophilic substitution? That you had benzene, right? I say you had benzene, and benzene had this electron cloud where each one had a p orbital, and they started overlapping, right? sp2 hybridized. So you had bromine. Benzene's electron cloud, this electron cloud did not have a very high charge density, so it was not able to polarize the bromine molecule. It was not able to knock out its electrons, which is why you needed a catalyst, right? And then one of the BRs went and natively bonded with the iron. The other BR, which was positive, it attracted one of the p orbitals and ended up bonding with it. Therefore, the electron cloud over here became partial and became positively charged because it had an electron missing. And in the next step, the H was the one that lost an electron, and that H then took electrons from Br and formed HBr, right? And the benzene electron cloud became complete again. Yeah, that was electrophilic substitution. It was a simple reaction. All you needed was a catalyst. And then we did the electrophilic substitution, which was called nitration, which was, okay, nitration method, you had a NO2 getting attached, right? Concentrated sulfuric acid and concentrated nitric acid were added, and temperature was 55. The first thing was that the nitric acid and the sulfuric acid, they reacted and they produced the NO2 plus 1 electrophile, which went to the benzene, took electrons from it, bonded with it. So the NO2 bonded with the benzene. Benzene needed its electrons back, so the H was the one that gave the electrons back. And in that way, the NO2 came in and the H got knocked out, right? So you clear that that's electrophilic? Is this clear that's electrophilic substitution? Ibrahim, Minal, is this clear? Ishaq, is this clear?
Yes, sir.
That's electrophilic substitution of benzene. So we just did benzene at the moment. Now, apart from benzene, there are other benzene-related or derivative compounds, apart from benzene. So this is your basic electrophilic substitution. Or then there are going to be a lot of derivative compounds, and we're going to talk about those derivative compounds now. Okay, so we're going to talk about the electrophilic substitution of benzene derivative compounds or benzene derived compounds. So these are compounds that have benzene in them, basically. So whenever you have, I'm going to make, here is the benzene electron cloud. And there's going to be some compound, let's say X, attached over here. And this X could be anything. So the first thing is this X could be an alkyl chain. So that, I mean, they're categorized into two different groups, these benzene derivative compounds. There are 2,4 directing groups, which I'm going to explain later. What are 2,4 directing groups? These are also referred to as electron donating groups. It's either there is three directing groups. Normally it's 3, 5. These are also known as electron withdrawing groups. Again, with the group, I mean this X over here. What is this X? So two different categories of groups. And I'm going to list those categories. So what could this X be? This X could be, it could be an alkyl chain. So if it's an alkyl chain, it could be CH3, or you can call it the alkyl group. Yeah, that's number one. It could be OH. Or you can also have ethers, which OR means an alkyl chain. So it could be, what else can it be? It can be an amine. These are all known as 2,4 directing groups. So you've got amines, and you've got different types of amines. You can have an amine with a carbon chain, or you can have an amine with two carbon chains. You can remember R is a carbon chain. And then you have Cl as well. That's an electron donating group as well. You've got amides, which is NHCO, NH, C double bond O, and then R. Okay, so that's how it's written. So I'm gonna write down their names as well. These are, so you've got hydroxy groups, you've got amino groups attached to it. As I similarly, I'm going to explain, okay, what do these groups mean one by one. We're going to do electrophilic substitution for each one of them. So basically, these groups are the ones that are going to push electrons. Okay, when these groups get attached to benzene, they're the ones that are going to push electrons towards benzene. Okay, so these are your electron donating groups. And then you've got your electron withdrawing groups as well, which are going to do they're going to do exactly the opposite. They're going to be the ones that will be withdrawing electrons away from benzene. So you've got lots of groups that do that. And one by one, we're going to study those later on. I'm just going to list them. So nitro groups, NO2, that is electron withdrawing. You've got NH3 plus 1. So you've got nitriles, they are also electron withdrawing. And then you have aldehyde and ketones. A ketone would be written as COR. Then you've got carboxylic acids and their derivatives. So if you have a carboxylic acid or maybe an ester, which is going to be COR, it's going to have a carbon chain at the end. So these are all electron withdrawing groups. This is a nitro group. This is nitrile, or if you call it a branch, it's going to be called cyano. Then you have aldehyde and ketones. Okay, carbonyl. and you've got carboxylic acids. Anyways, the first thing is, okay, what's an electron donating group? And we're going to start with the first one. Remember, the first thing is you got to remember who is electron withdrawing and who is electron donating. Who's going to push the electrons towards benzene and who's going to withdraw the electrons away from benzene. So one by one, we're going to study each one of them. So starting with the first one, okay, we're going to do electrophilic substitution. बल्कि E.S लिख देता हूँ. I'm not going to write the whole word. Okay, so we're going to do electrophilic substitution of arenes. Arenes are basically a benzene with an alkyl chain. Okay, that's what an arene is. Okay, that's a benzene with an alkyl chain. So when you have a benzene and it's got a carbon chain attached to it. So yoga and it's got a let's say it's got a carbon chain attached to it. And the carbon chain is, for example, CH2, CH2, CH3. Now, the name for this molecule is, it's basically benzene, but with the propane attached to it. So this one is propyl benzene. A simple name, it's going to be called propyl benzene. Similarly, you're going to have methyl benzene. So you need to know what, the naming is pretty basic. So this one is, so this one is propyl benzene, and you can similarly have methyl benzene as well. So methyl benzene would be if you have just one CH3. Now this thing would be called methyl benzene. You could have multiple alkyl branches as well. So if I have this and I have another one, so let's say I have another branch and that also has a methyl. So this would be called, you're going to count from the side that is the closest. So it's going to be 1,3 dimethyl benzene. Anyways, the naming is not that important because in benzene's case, systematic nomenclature usually is not followed because the naming is so complex that they just call it some random generic name instead of giving it a systematic name. अच्छा ये clear है 1,3 dimethyl benzene, is that clear?
Yeah.
अच्छा अब ये कि so that's 1,3 dimethyl benzene. Coming back to electrophilic substitution. Now, and the concept of what does 2,4 mean? So see, the thing is, benzene on its own, the electron density was evenly distributed. Where's the benzene electron cloud? This one. So on its own, benzene is very symmetrical, which makes it very stable as well. The electron density is like evenly distributed over the entire ring. They're all evenly distributed. But when you have a group that's coming in and that's getting attached to one side, that kind of disturbs the electrons that are distributed over here. It's going to get disturbed. So in the case of an electron donating group like methyl. It is electron donating. What it does is that the ring over here, the one that's drawn in the center, it's not going to be evenly distributed now. On one side, the electron density is going to be a lot higher. Which side is that? Because the electrons are being pushed from this side. That is why. So that is why the electron density is going to be slightly higher on this side. Clear? Is this thing clear that electrons are being pushed by the carbon chain? So that increases the electron density on this side. Is this clear?
Yes, sir.
And so what happens to the rest of the ring? Because there's a higher electron density on this side, all the other electrons in the ring, they get pushed or they get repelled to the left. And because of that, the electron density on this side increases, on this corner over here. So one side, the electron density increases, all the other electrons, they get pushed to the other side. And the benzene electron cloud is going to be higher on this side as well. So relatively speaking, when you have an arene, electron densities will tend to be higher at these positions. What are these positions? This is position number 1. This is 2. This is 3. This is 4. This is 5. And this is 6. So if you count it, it's 2, 4, and 6, right? It's these positions. 2, 4, and 6. It's these positions where the electron density is higher. So due to electron donating effect, of alkyl chains, the electron density is higher at positions 2, 4, and 6. I'm not counting 1 because 1 is where the methyl is attached. I said at positions 2, 4, and 6. I said normally you don't write 6 because position number 2 and position number 6 are kind of the same position. Malusko, if you just flip it around, 6 and 2 are kind of the same position. I said now the important thing is, so when this molecule undergoes electrophilic substitution, the electrophiles are now going to be very choosy about the position they get attached to. So your electrophile, whatever that is, let's say there's an X plus 1 that's coming in, it's probably going to get, it's probably going to be more attached to position number 2 or at position number 4 or position number 6. So electrophiles are more attracted to positions 2, 4, and 6. Yeah, so that's the only thing that you got to remember about electrophilic substitution of arenes. And the electrophilic substitution of arenes would be very similar to benzene, except that they're going to be slightly faster because of the electrophiles getting attracted to it. So I'm going to rub all of this. We already know what positions are more attractive because I've gotten rid of that. So remember, there was there was bromination and nitration. There were just 2 reactions. So what will happen is the product will be, you're going to get 2 products. If you do bromination, bromine is not going to randomly get attached to any position. It will only get attracted to positions. So it's either going to be at position number 2. That's where you're going to find bromine. Or it's going to be attached to position number 4. And I'm just ignoring 6 because 6 and 2 are kind of the same position. ये बात clear है?
Yes.
Yes, sir.
और इसका जो catalyst, it's exactly the same conditions. It's you need an FeBr3 catalyst, and your reagent is obviously Br2 aqueous. ठीक है. So this is going to be Br2 aqueous. ठीक है. And actually aqueous नहीं लिखना, not aqueous. And I guess that's it. And then there is, I said the names of these things. This one is 2-bromo methyl benzene. And this one is going to be 4-bromo methyl benzene. ये 2-bromo methyl benzene, 4-bromo methyl benzene, and that's it. और इसको highlight कर लेते हैं. That's so you have to. अब वो जो electrophilic substitution that we did, it's the same reactions, but they're going to be slight variations. ये बीच में क्या हो गया? अच्छा, इसमें ना there's just a few things. Reactions will be slightly faster. बल्कि इसको top पे लिख लेते हैं. Whenever you have electron donating groups, the reactions are going to be slightly faster. यहाँ पर लिख लेते हैं. You're going to get slightly faster reactions. In the case of electron donating groups. अच्छा, plus nitration भी था, so we're going to do nitration as well, which kind of is going to be quite the same. So I'm just going to copy the whole thing. Exactly same conditions for nitration, concentrated nitric acid, that's your reagent. And sulfuric acid was your catalyst. The temperature was going to be 55. Okay, we already did. The reaction mechanism. So you've got methyl benzene, and there's going to be no any differences. There's going to be an NO2 that's going to be attached. Sorry. So instead of Br, you will have NO2 attached. Okay. And the name of the molecule will be the name of the molecule in this case is going to be 2-methyl nitrobenzene. And this one is going to be 4-methyl nitrobenzene. इसका एक चीज नाइट्रो और मिथाइल, इसका मैं प्रेसिडेंस ऑर्डर चेक कर लो. Just give me 1 second. हाँ ठीक है. Nitro has a higher presence, so which is why you call it I mean, this one is called nitrobenzene. Was confirmed kara tha, sahi likha hua hai. Nitrobenzene has the nitro. I mean, there are two groups. So you call it nitrobenzene, and methyl is the one that's going to be. You're going to call its position. Okay, which is fine. और ये मैं bromine वाला भी confirm कर लूँ, bromo और methyl. Which one is बस एक सेकंड है, इसको डबल चेक कर लें. You put it here as a substituent diet. Just one second. ठीक है, पहला वाला ठीक है. अच्छा चलिए, but that's not that important. अच्छा, so the only difference you got to remember is, आवाज आ रही है सर आपको? So Isaac, Ibrahim, Qasim, is this clear?
Yes, sir. Yes.
ठीक है, so this one. I say, anyways, so that is arenes, right? It's a benzene with this thing. Let's go see. Okay. So this is arene and this is the electrophilic substitution. So you need to know it's exactly the same conditions and exactly the same with chlorine as well. So over here it could be AlBr3 as well. You complete or AlBr3, just like previously. Same with Cl2. And the catalyst would be AlCl3 or FeCl3 catalyst. I said now the next one is electrophilic, so that's arenes. The next one is electrophilic substitution of the other electron donating groups. So that is electrophilic substitution of phenols. These were the ones with OH. Okay, now a benzene alcohol is called a phenol. It's different from an alcohol. Okay, remember there were how many groups? 2, 4, 6 directing groups. We did alkyl chains right now. Okay, and then there is OH and then there is amine. So we have to do those as well. So, but remember, a phenol is basically a benzene plus an OH group. But what you also have to remember is that it's not an alcohol, although it kind of looks like an alcohol, but it's definitely not an alcohol. And it behaves differently compared to an alcohol. ठीक है, so if I have a benzene and I have OH attached to it, so that's a phenol. ठीक है, remember, not an alcohol. ठीक है, make sure you remember this. It's going to be different from an alcohol. It's a separate functional group basically. Electron donating, it's electron donating. The O over here has lone pairs, and these lone pairs, they tend to overlap with the benzene's pi-electron cloud. So the O has two lone pairs actually. And those electrons, they kind of mix up with the benzene pi-electron cloud, which is why the electron density tends to be, in this case, very, very high. And all the other electrons, they get pushed to the other side. And so they all get pushed to the other side. And so the electron density is going to be higher on that side as well. So again, it's 2, 4, and 6. But the only difference now compared to an arene, which is an alkyl benzene, is that electron density is now significantly higher at positions 2, 4, and 6. Okay, so the reaction in phenols, you're going to get the same electrophilic substitution reaction, exactly same reaction, except it's going to be like really fast. And the conditions are going to be a lot milder as well. You don't need catalyst. The electron density, because of these lone pairs that are overlapping with benzene, so the electron density is comparatively very, very high. Okay? So we'll do this to kal karte hain, we'll do this, continue with phenols, and we'll finish phenols and phenylamines, then we'll move to 3,5 directing effect. Okay? But ye clear at 2, 4, 6, is that clear? Minil clear, Qasim? Ibrahim, Isaac, is this clear?
Yes.
ठीक है, कल करते हैं continue, ठीक है? Okay, everyone.
Okay. Allah Hafiz.
Allah Hafiz.